Alright, hello. I'm going to read from the Pilot's Handbook of Aeronautical Knowledge. I'm in Chapter 2, page 2-7, Instrumentation Moving into the Future. Alright. Until recently, the GA aircraft, general aviation aircraft, were equipped with individual instruments utilized collectively to safely operate and to maneuver the aircraft. With the release of electronic flight display, the EFD system, conventional instruments have been replaced by multiple liquid crystal display and LCD screens. The first screen is installed in front of the left seat pilot position and is referred to as the primary flight display, the PFD. The second screen, positioned approximately in the center of the instrument panel, is referred to as the multifunction display, the MFD. These two screens declutter instrument panels while increasing safety. This has been accomplished through the utilization of solid-state instruments, which have a failure rate far less than those of conventional analog instrumentations. With today's improvements in avionics and the introduction of EFD, electronic flight displays, pilots at any level of experience need an astute knowledge of the onboard flight control systems as well as an understanding of how automation melds with aeronautical decision-making, ADM. These subjects are covered in detail in Chapter 17, Aeronautical Decision-Making. Whether an aircraft has an analog or digital glass instruments, the instrumentation falls into three different categories: performance, control, and navigation. The performance instruments indicate an aircraft's actual performance. Performance is determined by reference to the altimeter, airspeed, or vertical speed indicator, the VSI, heading indicator, and turn and slip indicator. The performance instruments directly reflect the performance the aircraft is achieving. The speed of the aircraft can be referenced on the airspeed indicator. The altitude can be referenced on the altimeter. The aircraft's climb performance can be determined by referencing the VSI. Other performance instruments available are the heading indicator, angle of attack indicator, and the slip skid indicator. Control instruments. The control instruments display immediate attitude and power changes and are calibrated to permit adjustments in precise increments. The instruments for attitude display is the attitude indicator. The control instruments do not indicate aircraft speed or altitude. In order to determine these variables and others, a pilot must reference the performance instruments. Navigation instruments. The navigation instruments indicate the position of the aircraft in relation to a selected navigation facility or fix. This group of instruments includes various types of course indicators, range indicators, glide slope indicators, and bearing pointers. Newer aircraft with more technologically advanced instrumentation provide blended information, giving the pilot more accurate positional information. Navigation instruments are comprised of indicators that display GPS, very high frequency VHF, omnidirectional radio range VOR, non-directional beacon NDB, and instrument landing systems ILS information. The instruments indicates the position of the aircraft relative to a selected navigation facility or fix. They provide pilotage information so the aircraft can be maneuvered to keep it on a predetermined path. The pilotage information can be in either 2 or 3-dimensional relative to the ground-based or space-based navigation information. Global Positioning System, GPS. GPS is a satellite-based navigation system composed of a network of satellites placed into orbit by the United States Department of Defense, DoD. GPS was originally intended for military applications, but in the 1980s the government made the system available for civilian use. GPS works in all weather conditions anywhere in the world 24 hours a day. A GPS receiver must be locked onto the signal of at least 3 satellites to calculate a 2-dimensional position, latitude and longitude, and track movement. With 4 or more satellites in view, the receiver can determine the user's 3-dimensional position, latitude, longitude, and altitude. Other satellites must also be in view to offset signal loss and signal ambiguity. The use of the GPS is discussed in more detail in Chapter 15, Navigation. Additionally, GPS is discussed in the Aeronautical Information Manual, the AIM. Chapter Summary. This will be Chapter 2 Summary. This chapter provides an overview of aircraft structures. A more in-depth understanding of aircraft structures and controls can be gained through the use of flight simulation software or interactive programs available online through aviation organizations such as the Aircraft Owner and Pilot Association, AOPA. Pilots are also encouraged to subscribe to or review the various aviation periodicals which contain variable flying information. as discussed in Chapter 1. The National Air and Space Administration, NASA, and the FAA also offer free information for pilots. But that's a test question. NASA, National Air and Space Administration. So you think you're smarter than a 5th grader? Or are you smarter than a 5th grader, right? Remember that? Alright. So we'll run through some quick instruments. Let's see. Alright. And we might go into Chapter 3, Principles of Flight. But that was Chapter 2. Yep, that was let's see what it's called. Chapter 2, Aircraft Structure. Alright. Take care, guys.